Chloroethene can be polymerized to form polychloroethene, commonly known as PVC. It's used to make pipes, window frames, electrical insulation. Plasticizers can be added to change the properties. So they've shown us some polychloroethene, then they've told us that chloroethene, which was our alkene from which we made this polymer, has a melting point of minus 154, but my polymer has a melting point at temperature over 100. Why does PVC melt at a higher temperature? Now, these two molecules have essentially got the same atoms, so we talk about the same intermolecular forces, but what we will notice is that PVC is a much bigger molecule. It's a polymer, and if it's bigger, it has more electrons. And if it has more electrons, the van der Waals forces between the molecules will be much stronger, because the van der Waals are caused by the electrons. Therefore, the van der Waals forces between PVC molecules, remember it's an intermolecular force, are stronger than those between chloroethene. And then the structure shows us the plasticizer for PVC, and it asks us to deduce the number of hydrogens in this molecule. So we have to do some significant counting here of a skeletal formula. Again, if you're running out of time in this exam, this would be a place to maybe come back, fold the corner of the paper, come back to it, because this is quite a big job. You've got to remember that every carbon has to have 4 sticks. So what I'm going to do is I'm going to add little dashes to represent hydrogens. So this one would have 3 because it's only got 1 stick. This would have 2. And this would have 2, and this would have 2. There's 3 sticks coming out of here, so there'd be 1, there'd be 2, and there'd be 3, and there'd be 2. This is an oxygen non. This is a carbon has already got 4 bonds. This carbon has already got 4 bonds. This has got 3, 3, 3, 3. This one's got 4. This carbon here has got 4. That's an oxygen. 2. This has got 3, so it needs 1 more. 2, 3, 2, 2, 2, 3. So now I have to add that up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. 38 hydrogens. Use your understanding of the properties of PVC to explain whether you would expect to find a PVC plasticizer used in PVC for insulating. Now, electrical cables need to be flexible to bend, and so we do need that plasticizer to reduce the intermolecular forces. So we'd expect plasticizer to be present, as PVC would need to be flexible. Okay. The next little bit says a section of a polymer of polychloroprene, a synthetic rubber, is shown. Draw the displayed formula for the repeating unit of polychloroprene. So we need to look for where this repeats, and this is not a standard polymer. So if we were to draw a little box round it, we can see that we cut just in front of that, like that, and then that repeats again here, and then again here. So we've got a Cl attached to a double bonded carbon, and then we've got a single bond. And then that carbon, and we have to do a displayed formula, so let's not fall into that trap that I was about to fall into. So this first carbon has a Cl on it. At the moment, so we are just drawing what's in the box. There was a stick coming out. We'll come back and check on the bonds, because we now have a double bond here to the next C. And that C has then another C here. That's a C, that's a C, that's a C, and this is a C. Then there's another, so there's 4 C's, 1, 2, 3, 4. This one must have 2 H's, then it goes to the next repeating unit. This must have 2 H's. This already has 2 sticks, so this must have 2 H's. This carbon has 3 sticks, so it probably has 1 H. So did you draw a structure? Now you could start in a different position, so as long as you repeat yourself, so you could have your boxes drawn slightly differently. did you get 4 C's where there's a double bond between the one with the Cl and the one with a single H, and then there's 2 CH2s?